That's great.
Okay.
Well,
That was AI.
good morning, ladies and gentlemen, and welcome to the Zero-Defect Manufacturing Cluster Workshop. My name is Juan Arrieta from IDEKO, and together with my colleagues Odd from SINTEF and Marcello from Polimi, we have been just promoting the cluster story from the very beginning, like 10 years ago. So thanks for attending here today. Thanks to the Commission representatives, to EFRA representatives, and the new coordinators. I know that we have been arranging this not with a lot of anticipation. We have been like hurrying up everything, but I think that we have considered it was convenient to have a quick landing of the new project today. Perhaps will be replicated in next year during the spring. But the idea today is to give a quick overview of the new projects and to have an open discussion with the new neighbor clusters on zero defects, on AI and on predictive maintenance, and to open a new discussion for the opportunities of zero defects manufacturing in the coming biannual work program and beyond. Okay. So this is the family picture that I hope that we have to make the new one, because this is coming from 2019, I think, before pandemic, and many things have been happening from then on. And the idea is to have this program today. We have some introductory words from EFRA. EFRA Commission representative will be also taking part in the discussion, the presentation of the current status and overview. I will tell you more or less which is the story that we are having with the zero defects manufacturing and where we are at the moment. Then we would like to give our word to the new coordinators for the new 6 projects accepted within the topic Twin Transition 0 and 02, especially zero defects manufacturing and zero waste, in a clear glimpse to the green transition. We also want to have a short participation of 2 clusters that are doing a very interesting pathway in predictive maintenance and AI for manufacturing. We'll have a short coffee break after. In the project that for zero, we are elaborating a sort of roadmap for zero defects manufacturing, and in 5-10 minutes we'll have a quick landing on that. And finally, we'll open a plenary discussion about the opportunities of zero defects manufacturing and the ideas that may enhance and may enrich this content of zero defects for the coming work programs. Okay. Well, this is not a formal event, so please interrupt me whenever you consider convenient. Raise your hand. Those that are the remote speakers, please also raise your hand. I don't see if somebody is raising the hand remotely. So, also, if you see that somebody is making a question, please interrupt me. Okay. Good. Sure. The objectives of the workshop, as told before, is that well, we are having a quick update of the running projects. We're not giving attention now to the past projects that are running, because some of them are in the midterm, but others have just recently started after summer. We want to put the focus on those new projects, okay? And the interaction with the clusters and the opportunities for zero defects, as I have been commenting before. First of all, congrats to the new projects. At the moment, it's not that easy to take a project on the twin transition destination. We know that the competition is fierce, and you did it. So there you are. So for us, it's a pleasure to have a continuation of the zero defects manufacturing success story with the new projects. And thanks for being here and also in the remote online attendance to all of you. Okay. Well, and why today in a hurry? Why today we were so interested in having this discussion, this workshop on zero defects manufacturing? Well, we consider that I see myself here and I want to disappear all these things. Okay. Well, let's see, now better. So there's a special momentum here. It's a convergence of several different facts. First of all, as I have recently told you, there's the European projects momentum. Some of them are in the midterm, others are just, they have just started. So it's a very interesting moment because we can just share, we can showcase the results that we are obtaining in the running projects, but also we are showcasing which are the plans and the ambitions for the new projects. There's a political momentum. We are on the doors of having the work program 23-24 already published. I think will be next week. So this is already done. But the strategy plan in 25-27 will be also started, and it will be the basis for the work program 25-27. And additionally, within EFRA, we are also about to start with the updating of the strategic research and innovation and development agenda, the multi-annual roadmap. So by all these facts, we consider the political momentum is also very interesting. This is social momentum because we have a commitment at the moment with the European society. We are talking about bringing back the high added value and excellence manufacturing to Europe again, attracting youngsters, putting the value on the excellence manufacturing, the high added value manufacturing. And we consider that the zero defects manufacturing can fit very well in this twin transition, in this digital and green transition, and can really empower all this community. And the technological momentum is that we are putting together now the projects that are coming from the digital platform for zero defects manufacturing, also those at the end of Horizon 2020 that were dealing with the digital transition and digital tools. In these are the topics that I'm talking about. The new ones that are giving, well, putting the focus on the green transformation, the zero defects manufacturing and the zero waste. And there's another parallel thing that is quite interesting and relevant. Within Manu Future, there's a working group on the DTI concept, the decentralized and distributed technical intelligence. This concept has been already presented in the European Manufacturing Conference at the end of September. And I think that we can really think on building bridges with this zero defects manufacturing concept. So by all these concepts, we consider that it was nice to have this quick discussion, this quick workshop, just putting together all this zero defects stuff. The DTI concept will be introduced a bit after with several discussions. We're talking about the systems optimization, distributed control, self-X real time. So I think it's an interesting concept that can be very well aligned with the zero defects manufacturing. It appears already in the Manu Futures RIA for 2030. So I really invite you and encourage you to have a look to that relevant document. So now, this is the storyline that we have had with the zero defects manufacturing projects. And I would like to give the floor to Laszlo Hitai, the project officer from the European Commission, that is our godfather within the European Commission, just to promote all these zero defects manufacturing issues. Laszlo, please.
Yes, good morning. I'm from HDR, and so HDR is part of the European Commission, but I'm not from the DG, so not from the policy DG. So I agree, zero-defect manufacturing is very relevant for twin transition, Green Deal, etc. But yeah, this discussion you should have with the DGs. Okay, this having said, so I'm very happy to be invited, and when I joined like 3 years ago, I could still see what is called here the third generation or the third wave. So I've seen, I think I went to 2 final review meetings. Yeah, the fourth generation, I think this is a project coming out from Connect calls. And then in the last 2 waves, I'm heavily involved. So I'm actually project officer of all 5 from the 5th wave. And just to say, I like all 5. So here we have 2 representatives from InterQ and that for Zero. After the summer, we had the review meetings of Optimi and I4Q, and all went more or less very well. With Spinilupe, we had the review in April, I think. Also, very interesting project. We have some administrative issues because they had, one of their pilots went into difficulties caused of COVID. And now we have the 6th wave. Initially, I think there were 4 projects. There was budget for 4 projects, but as there were so many proposals, they funded a 5th one. And now, from Brexit and the leftover budget, we could actually also fund a 6th project. But this project starts later because it's so the gap starts later and so on. I did 3 of these gaps, and I will be officer of 2 of these projects. So I know a little bit better Turbo, Flash Comp, and Platform Zero. Yeah, I'm very much looking forward to these projects. And okay, that's it. Good workshop.
Thank you, Laszlo. Thank you. Much appreciated. Please feel free to raise your hand and participate in the conversations as you consider convenient. That's nice. Excellent. So this is the overview, the success story that we are having with the zero defects manufacturing. This is an evolution of the zero defects. We started the machine process domain. Then we went to the multi-stage manufacturing systems. The time for the measurement, inline and inspection process, systems was also there. Digital platforms for zero defects manufacturing in 2018. And finally, at the end of the horizon 2020, we started to talk about the digital transition with all these projects, the 4F11 topic. And now here we are with the zero defects together with the zero waste concept. Which is the timeline for these projects? Well, green color means that they are completed, okay? Some of completed projects, yeah, is coming from the 2016. The green ones are in the midpoint, the middle point in the review meeting, more or less. All these projects here. One is about to be finishing, the zero defects manufacturing platform. And this is the similar information to the previous slide. The new ones have recently started after summer. So here we are. I think that we have to, it's our obligation as a cluster to keep an eye on the progress that the new projects are doing and just identify the most promising results, the research results, just to make it now to the industrial society to arrange future workshops or what we consider convenient. We are open to all the suggestions in that sense. A bit more details about the new projects and what's coming next. Well, the new projects have already started. We are proceeding with a joint dissemination activity among the related projects. This is strongly supported by our colleagues from Carr Communication. And we're also trying to make a sort of periodic catch-up and harmonization together with the EFRA events. This is the example today. In the afternoon, we have the Connected Factories event, and we have just taken the chance for arranging this workshop in the morning. As far as we know, there will be a large zero defects manufacturing event end of April in south of Spain, in Valencia, at the framework of this ZDMP project that will be able to finish in December this year. We have to go on analyzing and finding out the opportunities for zero defects manufacturing in the coming work program, the 23-24. I consider that our community should also contribute to the updating of EFRA agenda, EFRA strategic agenda. And I think that also is our obligation to keep sending recommendations to HADEA and to the European Commission guys, to the DGs, as Laszlo was commenting before, to keep these zero defects opportunities in the future work programs 25-27. Now we will start with the strategy plan 25-27. Let's find the opportunity for the manufacturing and for the zero defects excellence manufacturing in there. After this digital and green transition, there will be something else. There will come another part of the storyline, which is the next building block. Let's discuss on the open discussion now. The next generation of the zero defects wave. And we are a cluster on zero defects. We have another two neighbor clusters in predictive maintenance and AI for manufacturing. So I think that it's sort of inspiring to learn from each other and to have these short touch points. Okay. The 4C cluster is made up by these projects. We'll have a quick overview a bit later. And the AI for manufacturing is made out and composed by these other projects. We have our own website. This one is already running. Stay tuned. Contact us from that website of Zero Defects, and that was my initial overview. I don't know if you have any question. Also in the net, if it's any question, please raise your hand and interrupt me. Anything else? Now, Sergio, I'll go with you. Before going with the individual presentations, I will give the floor to Jelko from EFRA, because I was very dependent with all these, the presentations and the connection and this and that. I have started idly. Apologize for this, because it was, first of all, it was for you, Jelko.
I didn't want to tell up.
Yeah, but apologize for that. No Sergio, problem. You have a question, right?
Just a comment, Sergio Gusmeroli, Politecnico, Milano. For external liaison, I would also mention the DIH stuff, and in particular the two projects, Kit for SME and the IDEKO. which are also addressing and touching ZDM aspect from a DIH, Digital Innovation Hubs point of view. And this is another external liaison that could be useful.
That may be nice. Even for next future program, we can add some quick presentation about these two related projects. And I think that we can just set the boundaries a bit further.
And from January, the I4MS 2 project will start, and this is another.
Are they related with also the zero defects manufacturing concept?
Some of them, yes.
Good, good. Thanks, Sergio. Well, now, as promised before, let's go with the presentation of Željko Pacin, the Executive Director of EFRA. And there you are, Željko.
Perfect.
Done.
Juan, thank you very much. Welcome to everybody here in the room and online. I'm in fact very happy to see new faces because many people I'm here since long. I was there at the start of EFRA, and many people I know, but I'm very pleased to meet new people. It means the community is growing, and also, as Juan said, welcome and congratulations to these coordinators or participants in the new wave of Made in Europe projects. And in fact, for the newcomers, in fact, you are joining two communities. One's the Zero-Defect platform community, but then the bigger manufacturing community. And I will talk about this more in terms of Made in Europe, Factories of the Future, EFRA. It's a whole Manufuture. It's a long, big movement running since 20 years. And it's very broad and big community. And therefore, it's also interesting and necessary to have these sub-communities. So I'll give you a general presentation on Made in Europe EFRA, the history a bit, and also present to you the new calls that were already pre-published. So that's why I can do the presentation, because now it's official. They were pre-published officially. And end of November in the participants portal, everything will be opened and the calls are then are ready. And I know already networking is taking place and consortia are building for the next Made in Europe project. So that's the storyline of the partnership approach. As you know, stakeholders or we all meet at European level since many years. And we kind of meet with the Commission and member states and tell them what is necessary to do in terms of manufacturing research. But in 2008-09, this got a bit formalized, and we got the opportunity to enter into a formal cooperation with the European Commission in terms of a partnership. And this partnership was called Factories of the Future Partnership. And yeah, there were at that time already some JTIs, so joint undertakings, but for the manufacturing industry, there was nothing. There were some calls here from RTD, some calls there from DG Connect, but all a bit chaotic, and you couldn't plan it. You didn't know what the timeline was. And that's why both on the EU institution side and on the stakeholder side, there was everywhere a will, let's coordinate a bit better. Let's have a roadmap approach. So then EFRA was created to get the community together and to write the roadmap in terms of what's needed for production technology manufacturing research. And then this was then for the basis for the Commission to do call topics. And this addresses circularity, digitalization, digital twin, everything, but then zero defect and all these topics were also then an important part of the story. And so just to say, it's an evolution. It started a long time ago, so we know how it works. We are one of the oldest partnerships. We know how to manage it with the member states, with the Commission, with the different DGs, because in the partnership you have two DGs. I think it's the only partnership which involves the cooperation of two DGs, which means DG RTD and DG Connect. And zero defect historically was a bit closer to DG RTD. That's a kind of where it started. But then since the EFRA roadmap ignores the commission structure of DG Connect and RTD. You know, for us, it's all integrated, digital is everywhere. So that's why then, since the roadmap also mentioned Zero-Defect, also DG Connect kind of integrated Zero-Defect in their calls, and that's why you have also some DG Connect calls working on Zero-Defect. So just a bit on politics. So EFRA and the Commission and member states, they have these coordination meeting, political meeting. We signed a memorandum of understanding for this framework program. 900 million euros were reserved for Made in Europe, and it's now the first formal partnership we are executing. So there was FOF1, FOF2, and now Made in Europe running until 27. And we are kind of in the middle of Made in Europe. Half of the calls for Made in Europe were already kind of decided and published. And then, as Juanan said, we are now looking at the second half, where now we have a discussion and a consultation. What shall we concentrate on? What are the challenges of industry? Also looking a bit what was covered from the roadmap, that we don't repeat the same areas. So we also need to analyze what did we cover sufficiently. But the main question is what is the need for society, for industry? What are the future calls to be covered? So that's again politics. It's the general objectives and specific objectives of Made in Europe, of the partnership, addressing excellence, addressing circularity, addressing digitalization, product service connection, etc., and the human-centric approach. And in some of these things, Zero-Defect is stronger or less strong. Certainly, it was always in the first block there active. So you know, I put also some slides for later that it will be distributed. We cannot go through everything, but just to show you this, the roadmap. This was done in consultation with industry, with you. Either you directly contributed or through Juanan and Odd and others. We took your input into account when we did these consultations and the roadmap, and that's a kind of the whole framework. Just to say, because I see some people that I don't know, EFRA is a membership-driven association, so you can become member, but we also do kind of public events. So for example, here, these two Made in Europe stakeholder meetings. So please subscribe to the Made in Europe newsletter and join these open events. And if you find it interesting, please consider to become EFRA member. In terms of events, I just wanted to mention this European Manufacturing Conference. Some of you hopefully were there. It was 1-2 months ago, and it was a nice first big conference after COVID from us, and everybody liked it, I think. So now, or before I go to the next calls, just to say, I go back here, that what Juanan said, you know, we have this big community, and then we have clusters of projects or sub-communities, you know, on robotics, on AI. Manufacturing is so broad and so rich that you sometimes cannot cover everything at once. And that's why it's interesting and needed to have within the bigger family these subclusters, and you should be active at both levels. So for example, we will organize with all project coordinators of the new Made in Europe calls meetings taking place in December. If this information didn't reach you, just write me an email. Sorry. And to show you a bit the concept, to explain you the innovation portal. So there's an EFRA innovation portal where we map all projects, how they interlink to each other, how you can use tools to showcase what you are doing, etc., etc. So just to repeat once again, kind of you are part of two communities, this Zero-Defect community and the bigger one, and there are meetings on both levels. So now on the next calls, just to say that this is now pre-published. We did a newsletter this week. I think it's also should be on our website, where you can see the next Made in Europe calls. As I said, end of November, this will then the participants portal will be open for this. There will be info days in December. There will be so we did the internal matchmaking for these calls already, but then there will be one organized by the NCPs, the national contact points, also in December. So please use these opportunities to express your interest, to network, and to get into consortia for these kind of for these calls and other calls. So there will be 7 pure made in Europe calls. There's the 8th one, which is urban manufacturing. It doesn't eat from the made in Europe kind of pot, but it's also on manufacturing. It's linked to the new Bauhaus also. So that's also an interesting call. And outside made in Europe, there might also be opportunities for you to look at what other calls are available. But these are kind of the 2 calls, the 23, 24, which are now interesting. And then as we said, for later, we are now in this discussion, what shall we concentrate on in the future? Here are the main figures. And then you have per call a slide. I'm not going to go through this, but you can check this then when Juanan sends this around. I think this is what I wanted to say in total. So thanks for the organizers of this. And I think it's interesting or necessary also that you discuss the evolution of technologies, and from the Commission point of view and from the EFRA point of view, we always concentrate on project results, and for this also such kind of meetings are very valuable to see. They have to go more into details to help each other to see how projects what they do. To showcase this, it should be public, and then through presentations like today, you make it a kind of public, people learn and hear about it. We can put it then on the EFRA innovation portal, and in this sense then help exploitable results to reach the market. So a lot of attention is being to this. Yeah, what are the projects doing and what are the next steps, and how can we help that this enters the market and really has a real life effect. I will stop here. I'm also open to question either from the audience online or from the participants here. And thanks again for organizing this, Juanan.
Thanks to you, Jelko. Thanks for your kind words. Great. Yeah, totally right. You were mentioning, Jelko, that the manufacturing is so broad and so rich that we should be always keeping opportunities within the framework program. We don't have so many topics for the coming years. We consider that we should have more. But at the same time, we consider that other communities, other partnerships are finding opportunities in our community. So our battle and our fight, and this is something that we have already discussing within the partnership board of EFRA, is that manufacturing should also have opportunities in other different communities within cluster 4, in the data part, the data destination for the digital issues, in the digital emerging for the robotics part together with the AI, and in other cluster 5, for example, in neighbor cluster 5 also we should have opportunities. Keep in mind the manufacturing challenges that we have for the energy part, especially the renewables, the wind turbines, if they are offshore, there are huge manufacturing challenges there. There are also enormous manufacturing challenges in the shipbuilding, the aviation, automotive, the railways, but manufacturing presence in cluster 5 is not that much. It's quite scarce. So our messages to the European Commission, to HADEA, is always that we should have also these opportunities for manufacturing present in the coming work programs, not only in the Made in Europe topics, but also in other destinations within cluster 4 and additionally in cluster 5. Okay, great. After saying that, Jelko, thanks again.
Any questions, comments? If not, just drop me an email or to Juanan.
Yeah.
If not, something needs to be clarified later.
Great. So now the idea is to open the floor to the new coordinators. And let's follow the agenda. If you have any preference, especially I'm talking to the remote speakers, if you have any preference by any reason, because you have to go to the meeting or whatever, please tell me and we can rearrange again this presentation to the table. First of all, our idea is this one, but if anybody has another preference, please, now is the time. Okay, no voices in the room. I don't hear anything on the virtual room. So I would like to start the round with the new presentation for the new wave with zero defects, zero waste. I don't know how to say that, Oscar. ZDZW is very complicated.
That is tricky.
Zero defects, zero waste. If you have any other better way to just say it in a funny word.
ZDZW. It's more or less like we say.
Okay.
But you know, from the very beginning,
Great.
we already knew that it was
So Oscar
Oscar
from Ikerland will be the coordinator for this project. And well, Oscar, you have the floor. The presentation is here. Let's go to the presentation for ZZU.
Yeah, it is the first one.
This one?
Yeah.
There you are. F5 with the presentation mode. And you have the floor.
Okay, thank you, Juan.
You're welcome.
Okay, so thank you everyone. Thank you for the opportunity to be present here in this face-to-face workshop from the 4CTM cluster. Well, my name is Oscar Salgado, as Juan has already said. I'm the project coordinator from the ZDZW project. What I will be offering today is more or less like a general vision of how we are, which are our objectives, and what we'll be doing in the coming years. Okay, well, the outline of my presentation is the one you can see there. First, I will give you a short introduction to the project. Probably later on, I will continue with a more detailed focus on the pilots, what we'll be working on. And finally, I will be giving you a short glimpse of what we are going to produce in the project, our respective results. Okay, well, as already been said, this one is one of the very first new projects on this new twin green and digital transition that's coming from the Horizon Europe Work Program. We recently started just in September and will be working for 36 months. And we have a total budget of 11 million euros. We are a quite big consortium with 29 partners, where I think one of our main things is we have a quite good involvement from industrial SMEs, where we can have like 12 of them. Here you can see the logos and the names of our partners. Okay, so what is the need of the project? Well, nowadays the green transition is there, and we need to push for it. With respect to zero-defect manufacturing and quality management and so on, well, as we already knew, from the long time ago, there were some conventional quality control methods that in many cases for many industries were mainly based on destructive techniques. That is actually a way to produce a lot of amount of weights. And it's really not be really productive. So one of the focus of the goal and also the project is to try to bring new non-destructive techniques to address these limitations and to avoid the production of waste, mainly while maintaining high levels of quality and low levels of defects. However, as we already knew, these systems are probably complex, in some cases really expensive. So the high acquisition cost is there. It can be mainly a challenge, especially for small and medium-sized companies. And also, in some cases, there are complex solutions, and it may be a little bit complicated to complete their technical and digital integration with other systems available in the companies. To solve that is why we created ZDZW, where we will be developing advanced inspection technologies compatible with these digital-enabled manufacturing processes. Okay, so here you can see our main objectives and ambition, that is to develop digital non-destructive inspection services to improve production efficiency, zero defect, and sustainable manufacturing of European industries. We will be working on 3 different key areas. We know we will try to produce monitoring and control improvement for process quality assurance on the one hand. On the other hand, we will be working digitally enhanced rework and repair procedures for part recovery and scrap production. And finally, very important, we will push the continuous sustainability evaluation to ensure the efficient use of materials and components. Here in the project, we will be producing as a result 3 different inspection suites, which are actually different groups of different techniques and other circuit inspection techniques. We have 3 of them, one focused on integrity inspection, another one focused on visual inspection, and another one focused on thermal inspection. All trying to be interoperable and try to be interlinked with other system services and solutions. We'll be targeting 6 different use cases in 6 important processes like injection molding, injection hardening, welding, painting, packaging, thermoforming, and additive manufacturing. Well, we will produce different outcomes like the efficient use of materials. We will be available to produce alternative process control procedures, monitor and diagnostics of the processes, repair strategies, different preparation alternatives, and in the end also increase efficiency. Together with that, we are also offering like a whole digital ecosystem with a marketplace where different ICT or service providers, entity experts, system integrators, and skill development providers can offer their service in order every company in Europe can benefit from that approach. As in the results, they will produce some clear impacts, the ones that are focused by the Commission, being greener and more climate neutral. Okay, well, set this SDW doesn't start from scratch, as is a key part that complements an already created smart manufacturing ecosystem. We're going to provide smart factories with innovative monitoring, control, and predictive analysis services. We first started with a long time ago with the very first project that started in this line. This was called the BFOS, that were offering a manufacturing-oriented cloud platform supporting a multi-sided market system. Then we continue with this project ZDMP, where we continue that way in order to produce a zero-defect manufacturing platform where different experts, service providers can use their components in order to build new solutions that can be used by different companies, different industries. We also are benefiting from the work done from I4Q that complements in a way that they are also offering solutions that guarantee data reliability and functions around the data cycle. And finally, we SDW will be benefiting from all of that, complementing the whole ecosystems and trying to offer something that is not really present in all those different projects, offering those new non-destructive inspection services. Yeah, well, I will be. Sorry for that. Yeah, I need to be very, very fast. So we have 6 pilots. We try to have a different overview, different pilots who can benefit from it. One is mainly focused on plastic production with a lot of parts, million. We're also mainly focused on plastic reduction, where there is a significant need to be really, really effective, because a small 1% reduction can result in many tons of plastic waste produced at the end of the year. Also, quite similarly, regarding the thermoforming, especially from the white goods industries, well, a lot of plastic production is being involved. We are also trying to addressing new manufacturing challenges, especially in the renewable sector, in the wind turbine sector, trying to enhance different processes like the wind tower production, and also trying to develop some components that can benefit for it, providing more durable components like fastening solutions. Also, we try to cover different aspects, for example, from additive manufacturing, trying to where is also some really great challenge to reduce waste in the production. And finally, well, a quite common use case nowadays, like the packaging, where is a lot of plastic being involved. So really quick before I complete my presentation, what are our expected results? We'll be providing interoperable interlink service and solutions in the form of 3 different inspection suites. We will be pushing this concept, that is what we call the inspection as a service. Try to make downstream inspection more affordable to small and medium-sized companies by subscription or pay-per-use models. We'll try to maximize the industrial take by fomenting the skill developments of those technologies, and try to push the circularity going forward. That's everything from my side. If you want to know a bit much of us, you are invited to follow our social media there.
Thank you.
I'm just in
Oscar.
time. I don't know if any
Very
one of you has any question, any comment to make. So, Marcelo.
I would have a technical question. Thanks for the presentation. Can you say maybe 2 or more words, because I don't know how much time we have, on the inspection as a service concept? Because I would like to understand if it's only related to the AI part of the interpretation of data that is decentralized as a service, or more.
Yeah, for us, it's more like the business model that we want to follow. More or less, we are, for example, a non-destructive inspection provider, and especially we want to provide them the whole thing. Let's say I want to the company pay me like for the part that is being inspected, and I offer in the whole package, because otherwise, if I am a small company, I will need to buy this really expensive, I don't know, thermal cameras or something like that cost me like 30,000 euros. I'm not really an expert. I pay some guy, I don't know, from part of Europe, and I need to install there. In this sense, I offer the whole package. Well, I can give you some updates depending on the contract you follow and so on, and you are everything up and ready for what is your own goal, that is to produce good parts. So that's more or less the idea.
Thank you.
I'm eager to see which is the progress that you are doing with those suites and those promised results. So definitely, let's be.
Yeah, we'll be in contact for sure.
I encourage you to be part of this community, and in future workshops, I'm sure that will show you will show the progress.
Yeah. Thank you.
Thank you, Oscar. You're welcome. Well, good. Let's go now with the second. Well, now we're talking about, if nobody says the opposite, I would like to invite Cosmas Alexopoulos from LMS just to present the OpenZDM project. OpenZDM is in here. There we are. Cosmas, go ahead. You have the floor. Thanks.
Thank you, Hanan. Thank you for inviting us here in this workshop. So my name, for those that don't know me, my name is Cosmas Alexopoulos. I come from the Laboratory for Manufacturing Systems and Automation in the University of Patras in Greece. And here we're invited since we're coordinating the project called the OpenZDM, Open Platform for Realizing Zero Defect in Cyber Physical Manufacturing. So, of course, the project is under the same call as the previous project, and we started since June, and the duration of the project is 42 months. So practically right now we have finalized the definition of the requirements of the pilot cases, and we're about to start the developments. The project consists of 18 partners from 7 countries around Europe. You see here the names, and of course we have on board all the ingredients, let me say, research partners. We have end users, industrial end users. You will see more details later on. We have our software developers, and also we have technology providers that provide automation technology and technology for the production, and also a partner that is responsible for the dissemination aspects of the project. So also following the introduction from Juanan on the evolution on the ZDM cluster and the developments, here in this project, one of our main objective is to develop and provide an open platform based on the Ramming 4.0 architecture, especially the asset administration cell, in order to help bring together the different components that are needed for ZDM purposes that you will see now. So we want to develop 3 specific types for a non-destructive inspection, of course, that are related to our pilot cases. For the different processes that we have in the cases, we want to develop the digital twins to help us provide more insight help support the manufacturers in the decision making process, and of course data analytics. So we want to combine both data-driven approaches and model-driven approaches. That is more on the software side, integrate them on the platform, and on the hardware side, on the hardware technology, we are looking for 3 specific type of non-destructive inspection techniques that will help us on the decision-making process. So you see here the list of the objectives of the project, to have the platform to develop and integrate the non-destructive inspection techniques, deploy the digital twins, define the data-driven methods, and then have all of them into the platform that is the basis to deploy the solutions in the cases. And here you may see an overview how that will be achieved. I mean, in terms of the time plan and the work plan of the project. One work package is there for the NDIs. You see here X-rays for residual stress inspection, vision systems for inline defect detection, and laser technology for geometry measurement. These are the 3 technologies that we are employing in the project for inspection and quality purposes. Then on the same approach, now we go to the software side more. We have one work package for defining the AESs that will be used for encapsulating and accessing the devices. The digital twin technology, the data-driven methods, the analytics, and also the decision making for providing the algorithms for providing changes in the process, giving new values to the process parameters and changing the configuration of the process, which is on the decision making that utilizes the previous components. And as explained already, this is deployed in the platform that we bring from previous projects, and those solutions are deployed in the 5 cases that you will see more slides later on that we have. So this is the overview when it comes to the technical part of the project. I will skip this slide. This is maybe just a, let's say, typical work plan, starting from the definition of the requirements, and then, for example, we expect the first version of the system to be available in the month 12. Hopefully, next time that we have a next meeting, we have the chance to present more results to you. Okay, now a few insight into the cases. The first case comes from VDL. VDL is a company that is they're experts in processing metal parts, especially for this specific part is for the suspension system of trucks. They are located in the Netherlands, and there they have problems in the rolling form process related to the straightness and the thickness of the bars. Also defects on the surface, cracks. And this asks for NDI methods in this different multi-stage process to be able to locate the errors early in the process and then apply countermeasures in order either to improve or somehow adjust the process parameters and avoid future and further quality issues. So this is one of the case here. And we're going to see, as explained from the beginning, from the part arrival to the factory through the very late steps of the production. The second case comes from Volkswagen Auto Europa, located in Portugal. There, the question is on the alignment of assembly parts. There are quality issues in the early stages of the production, that the parts are like the side of the doors or parts of the body of the car are being produced through typical process like stamping, cutting, etc. But this creates problems in the final assembly and in the assembly stage, and we want to be able to locate those problems and then propose some countermeasures in the later in the upcoming process steps. And in there, we're going to use a laser sensor and data analytics to predict the possible faults. Third case comes from the good-based panel production. This is, yeah, it's, I'm 2 slides away. Okay, so next slide is on the good-based panel production. There are this case comes from Sonae, a Portuguese company. The objective is to use data collecting the different phases and be able to do what we call a quality, predictive quality that can predict the possible defects and also propose adjustment in the process parameters in order to avoid future defects. One more case comes from a company called Vidrala. They produce in bottles in Spain, and there the problem is because of lack of NDI methods. They apply more material to the bottle in order to prevent some quality issues, and they want to avoid that so that they save some material, and also to avoid quality issues such as cracks in the bottle. And there we want to apply a vision-based NDI to detect the cracks and save some potential waste. Last one is called from Aptiv. It's in battery detection. There the issue is on the welding process, and yeah, we want to ensure weld consistency. And here we plan for a vision-based system and data analytics for a real-time adaptation of the process during production. So these are the 5 cases. I hope you find some of them to be maybe for interesting for you. So if you have any comments or questions, please, if we have time, of course.
Oscar,
Yeah,
go ahead.
One short question. You call yourself open science. In what sense you are open?
In the sense that we want to apply the AES standard that will allow us to integrate the different solutions that can be either a new NDI techniques or new digital twin approaches or data analytics into the platform. This is the way this is how and why we call it open. We wanted to keep the interfaces and how to plug in different solutions in an open and the best way we can standardize manner.
Good. Well, Cosmas, many thanks for that.
Thank you, Hanan.
Definitely, 10 minutes is a very short time to present these and issues and challenging projects. But next time we'll have a full day, then perhaps, and not only 3 days. Now I would like to open the floor to Aitor García Lariedra from Lortec. He will present us the FlashComp third project, right?
Exactly.
So there you are. You're not that late, but you know, this starts accumulating.
Thank you,
Aitor,
Juanan.
go ahead.
So I'll be representing FlashComp project. I'm the coordinator, García Lariedra, and well, FlashComp acronym stands for Flawless and Sustainable Production of Composite Parts through a Human-Centered Digital Approach. So those are some general numbers. The project started basically last month. We have the kickoff meeting in mid-October. So basically now we are defining our use case requirements so that we can then define the requirements for the technological development. Duration is 42 months. And then we have the numbers for the project budget and also the funded part. We are 14 partners in total, coming from 8 different countries. And I would say that we are well distributed in terms of technology providers, RTOs, and use cases. So I will explain first the context of the FlashComp project. As the rest of the projects presented here, we know the current moment, how important is the transition towards climate neutrality, and in this regard, the need to reduce the waste in manufacturing. In particular, in the composite manufacturing, we know that this plays an important role in European Union manufacturing because there are relevant sectors in that field, like the energy, naval, aviation, and so on. And as a common factor, these manufacturing processes are based on manual operations, so are quite difficult to control. No? So there is a good opportunity there to improve those processes so that they are more sustainable. Because currently, we can say that there are an excess of material used and also some needs of reparation that makes the processes not very sustainable and not so efficient. So having said that, it was found out that there was a good opportunity to create an environmental impact by applying some digital solution that I will explain in the next slides. So having said that, the goal of the project is to develop a control solution, and I will mention 3 main features of this control solution, which I think are the ones to be highlighted. First one is that human-oriented solution, meaning that we need some interaction with the operators. That's the first feature. Second is that we need to identify in an early manner all the defects or the anomalies that may appear in the manufacturing process. What for? Because we want to take corrective actions into the process, which is the third feature. Okay. And this control concept will be applied in the composite field, in the composite manufacturing field, and specifically in a process which is called liquid resin infusion process. So if we simply define what the process is about, we can define the process into six different stages. The first one will be the design phase, then the preforming, where we give the shape to the part, the infusion process in which we introduce the resin so that we create the composite, and finishing operations, and the final quality control stage before we create the final product. So this is the current stage of this manufacturing process, and basically one of the measures that are taken to avoid defects currently is to introduce an excess of resin into the infusion process. Okay? So this has some advantages, as for instance, the avoidance of, or maybe more than avoidance, maybe reduction of the appearance of defects like voids or pores. But on the other side, we are introducing an excess of material. Okay? And not only that, we also are adding some some other operations like finishing operations like trimming, because we need to remove this excess of material. And then we have the quality control stage, in which we can decide if a defect appears, we can decide whether we can repair this or not. Okay. So FlashCom project comes to change this concept, and the question is, what if instead of relying on repairing operation, what if we introduce corrective actions into the infusion process? Because this is one of the most critical stages in this manufacturing process. So basically, this will allow us to reduce the excess of resin, the excess of material, which is one of the benefits. Not only that, this will also reduce the need of finishing operations. And the other point is that by introducing inspection and measurement techniques into the critical stages, the preforming and the diffusion process, we will also reduce the need of quality control at the final stage. So we will shift or we will move this process to an approach which will be much closer to the first time right approach. So for doing that, what is the suggestion in FlashCom project? So basically, we'll develop a digital approach based on three different modules, which I will explain in the next slides. It's the FlashIM, Flash inspection and monitoring module, FlashDZ, the defect severity estimation module, and the FlashDSS, the Flash decision support system module. That's how the architecture looks like. Basically, we have at the bottom the process from which we can extract data. Could be existing data, or could be data that will generate by the Flash IM. And we will have also obviously data storage. And an importance there will be homogenization of this data, because it will come from different sources. Then we have the FlashDZ that will rely on a digital twin, a particular digital twin, as I will explain later. And in this module, we will estimate or will predict the severity of possible defects. And based on that, we could develop the decision support system through which we can interact with the operator to give him some guidelines, or in the better case, we can control the process. So what we will develop in the FlashIM, as said, this will be based on inspection and monitoring instruments for a preforming inspection. So basically, this will rely on optical systems, linear scan cameras, spectral imaging, or 3D laser light profilers. For the infusion process monitoring, which is quite challenging, we will be introducing a Flash Leader to monitor the flow of the resin. This will give us very relevant information of the process. And not only that, there will be also embedded sensors, so we register the temperature, the pressure at different locations of the process. This will be done through fiber optic sensors, or a novel sensor which is called PiezoFlex. So in relation to the second module, the FlashDZ, 2 minutes. Okay. Well, the aim of this module is to predict the generation and propagation of defects, and will be based on an hybrid approach, meaning that we will combine physics-based simulations to see how the resin flows, and we want to run this near real time. So this will be reduced order models, and combined with artificial intelligence, so that we can compare the model with reality and adjust it based on that. And the final module will be the decision support system, whose aim is to determine the actions to be adopted to optimize the production, which could be in 2 different forms. Could be automatic orders, like actuating based upon different actuators, which could be, for instance, the pressure or the temperature of the inlet. or it could be in the form of assistance to operators through a human-machine interface. And for instance, one example could be the rearrangement of the inlet of the resin. And this will be applied to different use cases. One is the naval sector, that they are producing yachts, big parts actually. And the other is the aviation sector, which are, and the use case would be about the production of wind skin. And here you can see some of the expected numbers in terms of impact. So that's basically everything from my side. So if you have any questions, we'll be happy to try to answer them.
Thank you, Heitor. Thank you. Any questions in the room? Let's go ahead then.
Okay. Thank you,
Heitor. You're welcome. Well, I think that the presential presentations were already done, and now we have the possibility to have the two online one. And finally, we have also Engine. That Engine is in the room, but due to the last minute rushes, you will present directly from the website. It's already okay. It's also okay. So I don't know if we can see Victor Izquierdo or somebody from IDEK that is in the room just to present the platform Zero.
Hello, everyone. I'm here.
Yeah. Oh, let's wait a moment because I don't see you, and I want to activate. It's hidden.
Okay, I gave you co-host, so maybe you can share your screen.
Yeah. How can we put it larger? Does anybody know? I'm not an expert on the Zoom system. Just to put it larger.
The camera.
Camera is already there, but I don't know how to put this larger, you know.
Is it possible to double click the video? Victor's video.
Victor,
Yeah.
Can you share your screen, please?
Yes, please.
And see if we can, because at the moment in the room in Brussels, we only see the agenda.
But if you stop sharing, we're still sharing.
Oh.
Okay.
Now,
you see my screen?
We see it. We see it. So Victor Izquierdo from IDEK will present some words for the Platform Zero project.
Exactly.
Have the word. Go ahead. What about the sound from the bottom of the room? Can you hear Victor's words?
Hello, you listen me well?
Yeah, more or less. I think that it's okay.
Okay.
Victor, go ahead. Shortly.
Okay.
Now, in 7-8 minutes. Thank you.
Okay, I go fast, don't worry. Okay, well, first of all, thank you very much for inviting me to participate in this workshop. I'm completely, this comes from, I come from the community of photovoltaics. I'm completely new in this sector, okay, and it's very nice to participate with you and learn about these topics. I explained you a little about who are, well, what is our background. We come from the research of photovoltaics, that we identified some problems for the industrialization of technologies. And the Platform Zero appeared for try to solve this problem, the how transfer all the things that we make currently in research, that we have a lot high experience in research of materials and photovoltaic devices. But this, with the idea is to try to transfer these ones to the process monitoring in industries. Well, I go very faster. The first thing is that the motivation of these ones, the photovoltaics, the development of photovoltaics, is that helping in the transition to climate neutral. And in this topic, the photovoltaics have a big role. Because it's expected that in the 2040, the 20% of the demand, the 40% of the demand of the electricity coming from the photovoltaics. And the European Commission is funding a lot of projects or a lot of activities related to generation of new photovoltaics. The problem is that the development of these new photovoltaics is try to do compatible with a low-cost production, mass production, try to increase the integrability in different scenarios, like to integrate photovoltaics in cars, in buildings, in agriculture, in your clothes, in every place. Okay, try to generate electricity close to the demand. The problem of these ones is that photovoltaics, in the development of these photovoltaics, are complex structures, or requires a complex manufacturing process, and are involved a very high value materials. Well, it's a critical raw materials like indium, gallium, silver, and this type of the materials, well, they make some problematic in terms of the waste, no? The lost these materials during the production. Additionally, is that the Commission, you know better than me, is pushing a lot to develop, optimize the industrialization, no? The optimize the fabrication of products. And in this topic, focused in the photovoltaics, currently the photovoltaics companies, these emergent photovoltaics companies, don't have process monitoring, don't have clear control of the process, don't have automatizations, and currently have a high level of the waste materials and waste energy. So taking these two actions that we need to do, the idea of Platform Zero is combine the both, is new generation of photovoltaics, for give support to improving these ones and the transfer of these ones in the manufacturing, try to solve the problem of the monitoring, the control, and the waste of material. And this is the idea from the Platform Zero. Well, more or less, I explained very fast the Platform Zero. The idea is to create a platform. Okay, it's a physical platform with different modules that are very customizable, that allow to modify depending on the technology of photovoltaics that we need to monitoring. The idea is to integrate several techniques in different stages of production and combine these ones with machine learning strategies that allow learn first the self-learning the system, what is the type of the production, and after using this self-learning to control and provide information about what is the deviations, when happens critical deviations, and which is the possible mitigation actions that we can do. Okay. And in this way, that is expected to generate, well, we need to achieve 4 key exploitable results that are, the first is help to achieve the zero defects manufacturing of photovoltaics, this emergent photovoltaics. The second is create advanced essential stations. This is the concept of these ones is generate stations that characterize several parameters related to the materials and device that we need to analyze. Integrate artificial intelligence decision making based in the self-learning strategies that first the system learn about the production, and after using this information provide ideas or information about how mitigate the production of the defects, and finally create a holistic manufacturing control that allow control all the production line, and the idea is that it will be easy to transfer to another technologies like LEDs or like displays or another optoelectronics technologies. Well, the consortium is relatively smaller. This is in comparison with the previous projects. It's 11 partners. The duration is 4 years, and we want to, well, we do 4 demo sites in pre-industrial case, pre-industrial places, and in 2 in industrial places. The consortium is formed for different institutions from different countries of Europe, six countries, I think, yes, and involves companies from photovoltaics. Some plugged in Saules are 2 companies of photovoltaics, one in Poland, another in Austria. Research centers that have pilot lines for demonstrate the technology in industrial conditions in very high peril. This is the ZSW in Germany and Luderra in Spain. And there are research centers that are related to characterization, materials and devices characterization, okay, mainly for research and his transfer for industrial implementation. There are research centers related to the software, and there are a company from metrology that help us to integrate all this platform. Here I show you, oh, sorry.
2 minutes, Victor.
Yes.
Thanks.
Okay. And the platform is based, this is a scheme of the production, industrial production, that there are different steps, and the idea is to integrate these sensor stations in different points. And here the integration is integrate different techniques based in vision, spectroscopic, optoelectronics characterization of the materials, make all these ones in line conditions, and obtain information about the composition, the structure of the materials, the morphology, the device operation, and collect all this information and save in a database that integrate all the information and allow to following what happens with these materials or with the production during the pass from the one step another step, what happens with the material, that there are variations or not, different from the expected from the production. The next is we introduce artificial data processing and decision-making module, that the idea is take all this information on the baseline and first make a self-calibration, okay? This means that if you change the production for something, because you improve your production, now you make a first stage of self-calibration. And after, when we have trained these ones, we pass to the second mode, that is the control process, and taking the decision and provide information about what is the origin of the deviation. The last module is the control unit that centralize all the information and make easy to validate or use this platform. The idea is to do these ones without do an expert of all the techniques, expert of all the algorithms, expert anything. The idea is that are compatible with control from an operator, a qualified operator, but a operator that you can have inside of a company. Well, the idea of the platform is to do very flexible to change the one type of the production and the other. For this, we validate in these 4 scenarios that there are 3 different technologies. This is the ZSW, is a pilot line, it's not a real, it's a pre-industrial pilot line, it's for research and optimization of production. And this is for a high efficiency photovoltaic. This is a top of efficiency level. There are another demo site in Saudi company. The idea to here is provide a process monitoring that currently doesn't exist, that monitoring the perovskite photovoltaics technology. This is an emergent in that in the last 5 years push a lot. And the next is Sunplug. This is another company, it's a company that make roll-to-roll photovoltaics, a very high customizable. This produce photovoltaics to demand, depending of the shape, depending of the properties of the photovoltaic that is required for the application that he makes. For this, the process monitor is very complicated because change every day practically. When you generate a batch of photovoltaics, you need to change your production a little. And finally is Luderra, that is a pilot line, a research pilot line for nanoparticles for photovoltaics applications, for recovering the glasses and generate different functionalization of the glass that you have in front of the photovoltaic panels. And now the methodology I go very faster because now we are not started the kickoff meeting we will have in the January, in the middle of January, and the project is split in 4 phases. The first is identification of industrial specifications. The second is develop all the sensors and sensor stations and the sensors that we integrate inside. Develop the models for artificial intelligence and the data management and the control unit that allow to control everything. The first stage is implementation the full prototypes for the 4 demo sites, and the last is testing in real conditions in the 4 pilot lines or production lines. Now we are preparing the signature of the consortium agreement. We go later, but this is
You're on time.
the case. And the kickoff we are starting in January, in the middle end of January.
Excellent.
Thank you very much.
Thank you, Victor. Thank you for being here, although you didn't start the project yet. So that's really good entrance on the community. By the way, our idea is to share all these slides that we are showing today at the cluster website. So may I ask you to the remote speakers to send me the slides, and we will upload everything to the website that was presented. For sure, if you consider any specific slide, it's a bit confidential or whatever, and you prefer just to skip it, do it.
Okay, don't worry.
Everybody feels comfortable with the material and the stuff that we will be sharing after the workshop today. Okay? Good. So, Victor, many thanks, and see you soon physically. I guess.
Sorry for the go.
Excellent.
Thank you.
Well, no. So now the idea, yeah. The idea now is to go with this next remote speakers, that is Turbo and Julio Silva from the Technical University of Valencia, UPV, will be presenting Turbo. Am I right, Julio? You there?
Yeah. Can you hear me?
Yeah, we hear you. Please share your screen, and everybody here in the room will be listening to you.
I'm not allowed to share the screen.
Now you will be, I guess. You should find a button that says that you want to share your screen. Somewhere in the bottom.
Yeah, I find the button, but I don't have.
It's a green one, the green one with an arrow in the upper section.
Yeah, I find the button, but I can't. It's like I don't have.
Well, there might be like a security thing to make that you can share. Like if he's not the host, you can't share.
Well, we're gonna do that.
I'm not sure, but you could somehow make him go to his name.
Julio?
Yeah, I think you have to allow me to share my screen. It's like the host shall allow me.
Can you now?
Yeah, now I can. Thanks.
So also had the control from Italy. That's nice.
Yeah,
Great. Hello. Thank you.
So I told as a co-host you can also do that. Sorry.
Okay, so not Valerio Naranjo, but Julio Silva from the same organization from Valencia. 5 minutes every time that next speaker has like half the time of the current speakers, but I don't want to have any accumulated delay, you know. So in 5-7 minutes, I would appreciate if you can do it, Julio. Go ahead.
I'll try.
All right, good.
So I am Julio Silva from UPV, Politecnico University of Valencia. I'm on behalf of Professor Valerio Naranjo. We are partners of the Turbo project that I will introduce in a high overview in the next minutes, which is an acronym of Towards Turbine Production with Zero Waste. So this project is focused on wind turbine manufacturing, which are already part of everyday European life and are essential part of the strategy to meet the Green Deal targets. Still, the technologies used to manufacture these blades have not changed highly from the 1970s. Composite blades are manufactured using resin infusions and coating processes, which are prone to defects, resulting in high rates of rework, scrap, and repair. Thus, wind turbine production repairs have generated 1.5 million tonnages of unrecyclable scrap in 2020. So in the following, I will present a high-level overview of the project together with supporting technologies and manufacturing technologies that are the main core of this project. So we are 12 partners involved, 9 beneficiaries and 3 associated, combining both industry and technology providers and academic backgrounds. In this slide, we show the schematic overview of the Turbo project. The main objective of Turbo project is to combine several new developments from different disciplines to greatly improve the sustainability of wind turbine production by reducing defect formation and improving repair strategies in composites and coating. So we are centered on a demo production from high-scale blade manufacturing, and we will develop innovative solutions around this production, which will be based on three main cores. First, prior to piece production, the project will include simulation of production process to minimize the defect formation. We also will introduce in situ production monitoring, combining cutting-edge non-destructive testing technologies using dielectrics, wireless, and sensorless. And in the third block, we have an inline block which will monitor the control system using coating inspection via ultrasound OCT images and machine learning-based artificial intelligence algorithms for early detection of any possible defect to diminish it during the production. Also, we will make use of digital twins of the input piece to establish a digital planning online and make machine learning predictions. So this is the same view, but in terms of the involved partners that I briefly detail further. So regarding the supporting technologies, we have the first stage of simulation that will be in charge of DTU and SE. That will be a numerical simulation of the combined sensor data at the beginning for the piece. And we have the inline monitoring, which will monitor the location of resin during infusion, viscosity, and glass transition temperature. We also will develop embedded wireless temperature sensors, and this will be in charge of CPI and synthesis. So regarding the non-destructive testing of blade coatings, we'll be in charge of NCC and NORBLIS, and we will use the first industrial scale, large scale combined ultrasound and mid-infrared optical OCT scanner. These lower mid-infrared wavelengths can penetrate deeper than traditional near-infrared OCT systems, and we will use machine learning algorithms in charge of DTU and UPV to automatically detect any possible anomaly sooner. Finally, I will describe briefly the manufacturing technologies and the objectives we address in this project. First, as I said previously, we will try to use digital twins to better understand and monitorize and simulate the defect inspection and the control system, which will be in charge of SMARTIA and NCC. And we will develop a lab scale project to scale a whole blade section infusion process. Also, we will use improved composite manufacturing in charge of Hubers and Siemens Gamesa for better process through simulation and inline control by machine learning. So finally, transversally to all these technologies, we will make sustainability assessments in charge of the company IDEKO, which will develop circular pathways for production waste and will study the environmental and socioeconomic perspectives. And finally, as I said, all these innovations will be around a large scale demonstrations with a more than 80 meters piece blade that will be produced. So that's all. Thank you for your attention.
Great.
I try to be fast.
Thanks, Julio. Very short and intense. Nice
Yeah.
project. Also to you, if you feel comfortable, I would appreciate if you can send us the slides so we can upload it to the cluster website, right?
Sure.
Excellent. Very good. Thanks, Julio. So now let's go with the last speaker from VTT regarding project engine. Andres, you're here. You have been like recruited for this event in the last minute. So really appreciate it for being here. And let's go now. So here we are. This will be the last speaker regarding the projects of Zero Defect, Zero Waste. And then quickly, we should go with a quick overview about the two neighbor clusters. It will be a bit delayed, but I think that is not something dramatic. So Andres, go ahead with the engine. I need to share my screen so the remote attendants can really show it, can really see it. So let's go here. Instead of having some slides, which is your plan, I think that you will scroll down the website, right?
Yes.
Great, Andres.
Yeah.
Thanks. Go
Thanks,
ahead.
Juan. So I'm Andres Fremens from VTT. Today I'll be talking about the engine project. Anssi Laukkanen is the coordinator from our side, but he unfortunately couldn't be here, so you're stuck with me. With that, we identified a few challenges and solutions.
You can just scroll down with your finger.
Yes.
But as you can see.
Yeah. So the thing is that the metal products market is expected to grow to $3.1 trillion by 2025. Moreover, 83% of all of European Union's exports are manufactured goods, and certainly, European Union has a trade deficit of 22 billion in 2018, and that is not a healthy situation in long term. So we identified that we need to boost manufacturing productivity in order to boost our economy. With that, our solution is to reduce the environmental effect and improve competitiveness of metal products manufacturing by developing a novel metal product and design and manufacturing system. Moreover, we want to deploy it to a whole supply chain. As the project name suggests, we will be working with engines, particularly ship engines, and we will be demonstrating the system on a whole supply chain of pistons connecting rod manufacturing. With that, our idea is to develop this metal product design manufacturing system that integrates 3 separate modules. For data, share the data along the supply chain, we have the engine exchange. To do virtual design, virtual modeling, and calculations, we have the engine toolbox that includes both like physics-based modeling and AI tools. And then for non-destructive evaluation and different manufacturing techniques, we have the engine production models. All three of them will be integrated and deployed to a supply chain, starting with our steel manufacturer, Acciaieria Bertoli Safau from Italy. Next will be our forging company, Siderforge Rossi Group, also from Italy. Our machining company, which is Wärtsilä, Italy. And lastly, it's Wärtsilä, Finland, and that puts together the whole connecting rod and puts it in their manufactured engines. With that, this is how we envision that this system will be used. I'll quickly move this window so you can see it better. So the idea was that we usually start with some sort of an idea or an existing project, right? And we generally can define some specifications or requirements for that. When we have those defined, we use this engine system where we split the whole process in 3 separate parts. in real life, they're definitely not separate, but it's easier to describe them this way. So in design, we use the engine toolbox, which are the design tools, either physics-based or AI-based. We do the physics-based design, the AI-based lifetime assessment. What we want to assess is specifically when will these connecting rods fail in fatigue, as we have identified that's the leading failure mode. And then we want to integrate the LCA and LCC analysis already in the design phase, and also not only on kind of the environmental impact, but to also shape the business decisions. Usually we go through several iterations of these things, right? And when we have at least what we would consider the final design, we store it in the engine exchange, the module for data management. Next, when we go to manufacturing, we pass the material, the component designs and the manufacturing defect maps to manufacturing companies who do during their work, they do the production, the diagnostics. They use our AI damage recognition tool. We want to develop a separate tool to enhance our non-destructive evaluation. And when we get those results, we compare to simulated manufacturing defect maps and assess what would be the component's expected lifetime. We classify the component according to its expected lifetime and again, store the data in Exchange. During the assembly part in Vaasa in Finland, we assemble the engines based on our component classification based on their expected lifetimes and do the automated diagnostics through engine production. We use the damage recognition tool if we need to, and then we have the final decision. Well, is this acceptable? Do we need to repair or rework the parts? During the operation, we have from the engine system, I have the assembly defect data, the lifetime defect maps available, and we do the periodic inspections where again we use the damage recognition tool and assess our best prediction for the remaining lifetime of the manufactured parts. And again, everything is stored within this engine exchange. And at the end of life, we evaluate the wear and tear and make the decision, can we still refurbish them or recycle them and still store it in the exchange for easier access, for easier data access throughout the manufacturing chain. With that, we identified 10 objectives in total. 4 were the technical objectives. First one was to deploy and integrate this manufacturing system, which we see as the biggest challenge, as the many large industrial companies, each working with their own existing systems. Second one is to implement the supply chain and multi-site data management system. Third one is to create our computational tools, so physics-based, AI-based modeling, LCA modeling tools. And fourth is to develop a real-time non-destructive evaluation system. With that, we had 2 business objectives. First one was to increase the productivity, the competitiveness of our supply chain. And the second one was to increase the productivity of our SME partners and enable them to bring out the engine innovations to the wider world by enhancing their each products and services. Additionally, we want to we had the environmental objectives, where first one wanted to reduce the environmental effect of our industrial partners. And the second one, we wanted to enable other companies outside of the consortium to reduce their environmental impact by improving access to open source LCA tools. And lastly, we had a standardization objective where we want to follow existing standards, potentially investigate some gaps in existing standardization, and possibly provide some contribution there. And the skills objective, because we noticed that these new systems probably will need a shift in factory worker skills. Therefore, we have a dedicated skills partner, which will develop training courses specifically aimed for factory workers. If I have a minute, I'll show the consortium real quickly. This is not good. But okay, we have 17 partners in total, mainly the biggest country is Finland with 6, where we have Wärtsilä, Nome, GBW as our companies, Oulu, Tampere, and VTT as our research partners. We have Valmiers Technicums from Latvia as our skills partner, and it's a vocational school. From Germany, there's Green Delta and CIMAC. Green Delta is our LCA partner versus CIMAC is our standardization partner. Boku is a research partner from Austria. Ionex is an AI partner from France. Advantixis is the data partner from Spain. Then there is University of Padua from Italy and Wärtsilä Italy, Siderford Rossi Group, Aciari Bertoli Safau as our industrial companies from Italy. And last but not least, our great communication partner who made this excellent website, Talos from Cyprus. With that, thank you.
Very good, Andreas. Many thanks. I don't know if you have any questions in the audience before finishing the round with the project, the new project. May I ask you to use some screenshots and to prepare some slides? I think it will be automatic because the website is very clear. It's very sequential, you know.
Yeah.
And if you send it to me, we can upload everything to the website,
Yes.
the cluster website.
Yes, I think I'll make a dedicated slide deck for you.
That's great. That would be great.
Yeah.
Thanks, Andres.
Yeah.
So you see 6 new projects, extremely interesting, challenging, ambitious. They have all the ingredients to succeed. And I think that our idea is to count on you and your progress for the next events that we may arrange from the cluster. Okay. So now we are in the coffee break, but my proposal would be to have a quick presentation of the 2 clusters and then go for the coffee break. Do you agree with that? Yeah. So now, Cosmas, I would invite you again to the stage just to see. Wow. How can I escape it?
You cannot.
Oh. There we are. So let's go to the which is your presentation, Cosmos?
4C cluster.
4C, this one. May I ask you like 5 minutes? Is it okay?
Yes, I will repeat, but just informative on the cluster.
That's it. That's the idea. And something similar will be also asked to John Soldatos with the other cluster. Great.
Okay.
Thanks, Cosmos.
Thank you, Juanan, again
But
for
this is a cluster now. We're not talking about projects anymore. Now we're talking about similar clusters. Ours is Zero-Defect Manufacturing. Cosmos will present one in predictive maintenance that is coming also from 2016 OS. And then there's another one that is much more recent under the ICT 38 topics on AI for manufacturing. That is the AI for manufacturing cluster. Cosmos will present the 4C cluster.
Okay, thanks a lot, Juanan. So 4C is a cluster that has been initiated back in 2016 with the projects working on the topic of predictive maintenance. There was back then a group of projects that you see some of the names here, like Prophecy, Serena, ZBreak, Precom, Uptime programs, that they work on the topic of predictive maintenance. And now, since these projects were now over, we have instilled the cluster with new projects that are working on different topics like AI or in a predictive quality. And yeah, so we're going to enhance the cluster with additional topics that is not only predictive maintenance, but as I said, predictive quality, predictive energy, and so forth.
Sorry.
And here
Can you share the screen? Because online we cannot see it.
Maybe we cannot share it. ¿Cómo está?
Yeah, this one, the green one. This
yes.
screen. That's it.
Can you see it now?
Now, well done.
Yeah, yeah, thank you.
Okay.
Thanks for letting us know.
Okay, so you see here the thematics that we are working upon, predictive maintenance, quality, analytics, energy, and also we see some cross-cutting aspects like skills and competencies and standards. Yeah, so I will skip this slide. I will just focus on these two slides. One of the results that the cluster has achieved in its during its operation is to publish this white paper that is on the predictive maintenance. It is published in July 2021 and it is available online now. You can download it and go through it. And now we are working on a new white paper with a new project. Here we're going to see more broadly predictive operations in manufacturing, not only predictive maintenance. And also we're going to see technologies behind it, pilots that are related to those technologies, and aspects such as standardization of those technologies. So this is a work in progress. We expect to have it there published in summer 2023. This is our objective. Let's see if this will be achieved. And in the context of the cluster, we have participated in some dissemination events, like in the INTEC event in summer in Grenoble. I mean, this gives us the opportunity for the project members to join efforts in doing not only technical work but also dissemination work. Yeah. So the cluster is open. I mean, we are now also in contact with some of the projects that they are on the new project on ZDM, if they want to join and maybe contribute in the white paper. And of course, we are all in close cooperation with the ZDM cluster, with Juan and the team here.
Always inspiring to see what are you doing from the other neighbor and related clusters, and especially let's stay tuned for the white paper that they are progressing and they are elaborating for next summer. So. Many thanks.
Thank you, Juan, again for inviting us here.
Thanks to you for being here. And something similar will be also done with the AI for manufacturing cluster. John Soldatos from Intrasoft, are you there?
Yes.
Hello, John.
Nice to see everybody, and thanks for inviting me in.
Long time.
Yeah. May I share my slides?
For sure. I have. You should have the control. Just try it.
You?
Yes. I can see it. I think I have the control, but let me.
You should have a sort of share screen button at the bottom of the screen with an upper arrow.
Okay.
Oh, we have it. We have it now in presentation mode. Great, John. Go ahead.
Great. Okay, so I'll be quick. This is the ICT 38 projects cluster. We call it AI for Manufacturing. We've got a website, AI for Manufacturing .eu. I don't have so much time to go and explain what its project is doing, but just for you to know the names: AI Proficient, Assistant, Koala, Knowledge, Mass for AI, Star, that's actually my project, teaming.ai, Xmanai, and a project that has just finished, EU-Japan.ai. This was more a coordination action type of project. Now, I'm not gonna give the details. I'm just gonna explain very quickly in that slide what these projects do, more or less. Of course, they are about artificial intelligence in manufacturing. And I noticed in some of your presentations, previously in some of the ZDM or ZDM Zero Waste presentations previously, that you use AI. So the distinguishing line here is that we are just talking, about more advanced forms of artificial intelligence, like
John, wait a moment, because we have some technical issues here, and the projector has turned off.
Okay. I'm waiting your call to continue.
Your explanations. It's like when the light is turning off, something similar is happening in the room. And
yeah, sometimes the digital infrastructure is more resilient than the physical one. Sometimes, not always.
it's great that you are also here because the cluster, well, these are quite recent topics. ICT 38, it's about the last year of Horizon 2020. Perhaps the zero defect comes from 10 years ago. 4C is from 2016, more or less. But this has started around last year, I think.
Yeah, it's a little bit more, 1.5 to 2 years. Some projects are already running for 2 years, right?
Oh,
so what I was saying is that some of your projects are using artificial intelligence, but this cluster, the project in this cluster, go beyond, simply using machine learning, right? On some use case. It's about trusted and explainable artificial intelligence in industrial use cases, also focusing on the human factor and the human-robot collaboration, the cobots. So all of this, some people, I'm not one of them, but some people, in Europe, they call it Industry 5.0, right? Maybe you've heard this term, right? Because it has very evident the human centricity, right? The human-centric aspect and the sustainability aspect. I think I can go on, right? Or is it okay?
We don't have a screen at the moment. It's very uncomfortable position, but I don't know if you consider that we are a sort of blind audience. Just perhaps you can comment some messages that you are doing.
Yes.
Radio transfer.
And we'll do our best. Yeah, I see it here. Yeah.
Maybe let's take right now.
Yeah, good idea, Andres. John, we'll try to sort out the technical issues. Technician is coming. We can stop for the coffee break and we can continue with your great explanation on the cluster after the coffee break. What do you think?
It's up to you. Whatever you tell me, I will do.
We will stop for 10 minutes.
Okay.
Thanks for your flexibility. We'll stop for 10 minutes and we'll come back after more or less 20 past.
Okay.
Just to continue with the cluster explanation, okay?
Okay. See you
apologize for these technical issues, John.
Okay. See you in 10 minutes.
Thanks. I don't know what happens here because everything was smoothly and then suddenly
maybe it's alarm. Could you try to fetch the presentation or something?
Yeah. Okay. In the meanwhile,
if no one can see the screen, so let me know. There's one.
So it was not the laptop, it was not the Jabra speak, but it was the projector. You should never expect that the projector is failing that way. But anyway.
At the end of the coffee break, we're waiting the news photo.
Yeah, please.
I think after.
I don't know where, if in the room here, the entrance in Diamond.
It's quite nice if we can all face
This one,
in the background.
it's nice.
If we turn on the lights. Or
Sure, taking out all the luggage from
in
the middle. Great, Linda. See it. Check the projector. Right there. Sure. What do you think?
I think the projector is problematic.
Really?
Yes. I can propose an external screen. Change the room.
No. We cannot change the room.
I have a screen 75 inch. The screen is more on this, but it's a big screen.
Odd. Yeah. We have a problem here. The projector has died.
Yeah.
I think that we will propose John to finalize his participation, at least in a verbal way.
Yeah.
Then, but we have the problem with you now because you have a
I can do the roadmap.
how can you do it?
Skip the DDI.
Do you have a lot of preparation materials? I can do the roadmap. So in that case, changing the route.
The external screen, it's easy. It's 5 years, in 5 minutes.
But you will need a new projector, right? Sorry? You will need a new projector.
I think it's the lamp, but I can, you speak not French?
No.
I have a big screen when you connect with a HDMI cable.
Yeah.
Well, let's do that.
Yeah,
Let's do that. 5 minutes.
Yeah.
5 minutes. Okay, let's do that.
What happens? Doesn't work anymore. No, it came back on the neutral tone again. It was on for 3 seconds. Then there is something wrong with it.
So now they are looking for a portable screen.
Yeah. To be careful.
The pity is that John was in the middle of the presentation and we have another one of that of the roadmap. Yeah, then it was after the roadmap, it's only about the discussion. But we are not still there.
I can do the roadmap and I don't need to do a presentation for the DTIT. I can just mention.
Okay.
Okay. So I do the roadmap and then we start discussing. Because we are a little bit late as well.
Okay, good. If we can recover, it would be great to have the situation with the screen, but.
Or I can do it very short. If you use a screen, people can do it. You need a discount. Yeah. Of course. A big discount.
Well, after meeting, so after price.
It's Black Week. Black Friday.
I don't see the discount.
I know that at the end of April, May, June, this month will be very, very busy. in the evaluation. July is the holiday for many people, especially in the countries, also in the but I could think of after summer. I am late, but
it's possible because they might take some hours off. I think it is important. I can travel because they have always much to do.
Yeah, always much to do. Yeah, this is not the part.
And it's cold in the autumn, September, it looks 60 very neat.
Yeah.
Feels all right. Yeah. You have next step of the ceremony, before the October. We have something. No, we can have it already lawyer, you can have it just after the due date, because they are always taking some dates to organize papers and starting the process. So the week after, there are always too much. They have a heavy workload.
Yeah. Now we change the screen and you guys have been looking for another screen. So now we are looking for an alternative just to proceed with the complete presentation of John and then go with the presentation of all. And let's open the discussion, but we have only 1 hour to do everything.
1 hour, if we finish, we can keep on perfect.
We must.
I was going to ask, if you want to open the questions on screen, then put them together, so Marcello's question that he sent yesterday, and then your GTI question is this. Will we want to have them up on screen? So we're then what? Yeah. I think it might be easier, yeah.
To hear. So which are those slides, Linda? This one? The panel discussion. Great.
It's just 2 slides.
Done.
Thanks, Linda.
Stick to it or not, we'll see what some time allows for.
Well, this is the big one, right?
Yes.
Have you ever had problems with the projector so far?
No.
Well, by chance. It was-
No.
Anyway, that's good option.
Should be okay. You can do it. You can go to the road. Don't need to sit in the back.
Yeah.
You need the HDMI here, connector is here. That's it.
Le pupitre.
And perhaps we can even take the chance of using the audio system on the screen. That is really-
You can,
What do you
yes.
think?
Yeah.
Yeah.
If you have video or something like that, yeah, I think it's better.
More than videos is that there are some remote attendants to the event that are speaking from the distance.
It's with Teams or Zoom or something like that.
Let's see. Yeah, it's similar. It's
Okay. So you have just to change.
The microphone, you need to use this one,
Yes.
but the speaker you can change to the screen.
Okay. And what about the remote speakers? Can they speak through the screen?
Yes.
Yeah, but you
John, you there?
but you have to keep this one
Can
just.
I start presenting?
No, just we are making some technical testing. We are changing the screen. So checking out if you can speak through my Jabra speak or through the TV set that we have arranged in here.
Microphone, c'est bon. Et là, c'est. Là, tu l'as, hein, Samsung.
Ouais.
Can you check? You speak?
Yeah.
Can someone just
Now
speak?
I'm checking. I'm just checking it.
Est-ce que someone can speak?
John, say some words, please.
Yes, can you hear me?
Hey, yeah. Now it's very good. Yeah, we can. I think we can continue. I will stop the coffee break, and we can continue with this. Thanks.
You're welcome.
Many thanks for your support. Very efficient.
We are here for that.
Oh, come on.
Enjoy.
It was something unexpected, but brilliant. Thanks. So, I know that. I am quite sick. Or do you want me to? Should you? I need to. Hello? Hello? So let's get back. Thank you. John, here we are.
Okay, great.
So please apologize for this unexpected issue, but finally the technical assistant guys have replaced another screen and we are operative again.
Great. That's important for the workshop to continue.
Continue with the cluster explanation, please, John.
Okay. So I was just saying that in the projects that were presented previously, many of them use artificial intelligence, but in this cluster, it's a little bit different. We develop advanced artificial intelligence for manufacturing. This means trustworthy, explainable AI, AI based on counterfactual explanations, and also human centricity, human-centric artificial intelligence. So there is a spectrum of topics. I would collectively put them closer to human-robot collaboration, to trusted AI, and maybe to what some of you call Industry 5.0 these days. Now, as we mentioned, the cluster is running for 2 years. So we have been doing different things like some scientific collaborations. We are preparing some joint publications like an edited book and a journal special issue. And we have run a series of workshops, which are, for education and training, but also for creating awareness in the community about advanced artificial intelligence topics. So there have been 4 workshops so far, one on explainable artificial intelligence, another on the ethics and the legal issues, one on human-centric manufacturing, and most recently on AI interoperability. That's one book we have also published in the STAR project. I'll put the link so that people can download them for free. If you can share the link, Juanan, it's a free book.
That's great.
Trusted artificial intelligence, so I would like to share. We have task forces, like a task force for digital assistant, and we are open to participation. And I would like to end up with this slide. Of course, we are collaborating with different clusters and initiatives. Main links are with EFRA, of course, with Digital Factory Alliance. We have run with them joint workshops and participations in open dialogues. BDVA Dairo, because we are artificial intelligence here, so this is an important association for us, and we are willing to strengthen our collaboration with 4ZDM, and thank you, Juanan, for inviting us. So that's all from my side. I'm available. You have also my email, and looking forward also to connect with other members of the cluster. Maybe a final thing that I didn't mention, and this is very important. From our cluster, we are putting a lot of results. We are planning to put a lot of results in the AI for EU, artificial intelligence on demand platform of Europe. So we plan to put a lot of results there, and maybe to create a manufacturing section, because in AI for EU, you have hundreds of results. We plan to create a manufacturing section, and we are investigating how to do this. So if you have similar concerns, feel free to reach out. We can give some answers.
Makes full sense, because AI for you, it's a huge project with a lot of energy, health, or societal applications. But if we are just extracting or filtering them by the manufacturing applications, makes full sense, John. Let's keep in touch to fine-tune that contributions.
We are building a class. We are building a catalog for manufacturing there. Okay, and this might be important for some of your projects.
Absolutely.
Connect to this platform.
Absolutely, that's great. So,
Thank
John,
you, everybody. Enjoy the workshop. It was really a pleasure, and I remain available.
Many thanks to you, and especially thanks for the flexibility you have shown. Apologize all these technical issues out of our hands, but finally there you are, and you have finalized it. I'm happy to hear that. Thanks,
Thank
John.
you. Thank you very much.
Keep in touch. Bye-bye. Great. So the idea now is to go on with the program, and at the program what we had is just hold a second. Coffee break is already done, thank goodness. And we are at the DAT40 project. Remember that it's an FOF11 2020 project, led by SINTEF, and Odd and Marcello participating together with me because IDEKO is also part of DAT40. But we are elaborating a sort of roadmap, ZDM roadmap, that may have a predecessor and antecessor in the Focus CSA sometimes a long time ago, where we created a roadmap on zero defects. But from then on, all the digital issue has arisen on the SEN. So we need to upgrade and update all that roadmap. And I guess that this contribution from DAT40 project will go in that direction, right? So Odd, Marcello, I don't know who will be the speaker here, but I will show, I will just open the slides that you were sending to me, right?
Yeah.
Which are they?
The way forward.
The way forward.
That's the roadmap.
Surviving to all the technical hurdles. How can you see it? It's okay?
Yeah, and then
So,
just press down.
And I don't know, why can't we see
The
it?
sharing.
That's it.
Okay.
Do you need a pointer perhaps here?
No, it's
Okay.
okay.
Good.
Okay.
Go ahead.
Thank you. Why DAT40 is taking a lead in this is very simple. It has a deliverable that is going to be finished by the end of October next year, which is called a Zero-Defect Manufacturing roadmap. That's why we have to do it. And I hope also it's an open deliverable. So I hope it's possible. Also, we need to do our contribution and submit it. But I do hope that this can be an activity also in the 4ZM cluster, and that is possible to have other projects also to contribute into this roadmap. I think also that big digitalization that has happened after 2016 is important to cover, and to the way forward that, and also the sustainability and the circular economy and all those kind of things, the green transition, and also other issues that shows up. And zero-defect manufacturing is a highly technology-intensive and strategic manufacturing approach, and we knew that. We see all the projects that have been working since the early beginning 11 years ago. And we have also foreseen some mega trends that may influence zero-defect manufacturing in the new road mapping activities. And also there are challenges for tomorrow. We have seen a lot of current thing about resilient manufacturing. That has been a high topic now, and also technology knowledge transfer to the generations, how to use it, and the human-centric manufacturing. But we also have other activities on, and also there are a lot of things in manufacturing as a service, customization, and also keep everything with a zero-defect view and deliver quality in the manufacturing. Okay, I'm using this once again. It has been mentioned, but the red line shows the last roadmap. It was in 2016, and it was the CSA Focus project. To just make a comment on that, we also made a roadmap for maintenance and some other ones. I think also the other cluster are building on this activity. 5 clusters. 5 clusters. One of them were maintenance, and one were zero-defect manufacturing,
technologies,
and micro manufacturing. So afterwards, there's been a lot of activities going on. So it's here it is. It's a little bit not updated. It's from 2016, and now we feel the time that to make new contributions, and also that we can influence the future trends for 2025, 26, and so on. And we hope both to work with Many Future and with EFRA and all stakeholders, even also the Commission, of course, and see how this can be developed. There's a lot of stuff I will distribute to the slides. We see more complex manufacturing systems. We see the digitalization and the technology adoption is going to be implemented more, and the sustainability, the Green Deal, and the human-centric manufacturing. How will a human future workspace be? We still want to have employees in the factories, even they are highly digitalized and also automated, but this is an important aspect. So the digital enhanced quality management, the DQM implementation that we are working on Data for Zero will be something we are starting with and see how this can be transferred further into a roadmap. But as I said, I do hope that we can include other projects and other activities into this work and see how we do that in practice during next year and also up to 2024. So the zero-defect manufacturing has a strategic landscape. Application sectors until now, it has been very much focused on the discrete manufacturing, but we see that any industrial stream is relevant for this, and we also see also some other projects that has other industries are coming, so that is important. And we see also aspects of bio manufacturing, novel energy management solutions, circular economy, and decentralized technical intelligence concept, and the role of the humans again. We have this is more or less for some research priorities, and we also will come back to this as question for a panel discussion that we have. You want to add something to it now, Marcelo, or should we keep it for as an appetizer introduction to the discussion?
Yeah, let's keep it for the.
Yeah. So this is an intro. This is really the first time we present the plan for this and how we want to work with it. And as I said, I hope this can be a issue or a topic also for the future zero-defect manufacturing activities in this cluster. Thank you.
Great. Well, so let's stay tuned for the roadmap. When is the timeline that you're expecting for this roadmap delivery?
The deliverable for Data for Zero is in September 2023 next year. It also forces that we can work on it afterwards together with other projects and so on to see if we have it a little bit later. Should be okay for my side, early 2024. So we don't have just that deliverable.
Okay.
But we have more. That's my idea with it.
War is changing dramatically in this sense, and we have to
the deliverable has to go through anyhow. But
yeah, sure.
But it's an open document, and we can exchange it, and we can add more on it from other stakeholders.
That's it.
Yeah, we can do the draft. Like we did that. It's not probably six again.
Good. So finally, time to start with the open discussion, the panel that we were commenting before. Well, I think that we'll have like around 20-25 minutes to do that. And I'd like to give the last 5 minutes for the wrap up, some conclusions, any comment from the audience here and on the Zoom connection. So how are we doing this panel? I think that we can move this table just in the center, perhaps. We can sit here, and I will open. Linda was preparing very kindly some discussion points in here, and I think that we can start just addressing these discussion points. We would really appreciate the participation of the audience. I mean, we can be here talking about everything till Christmas, but it's not the plan. It's not the plan. So the open discussion, how can you see it? It's okay. Yeah? Well, it's okay. Good.
That's great. So welcome to the panelists. As the ones who aren't in the room, were we saying we'd move the, no, we won't be able to see. Okay. Okay, so I'll just, the remote participants won't be able to see our lovely panel here, but we have Dr. Odd Myklebust from SINTEF, Professor Marcello Colledani from Milano, and Dr. Juana Arrieta from IDEKO, who are our panel today. And as Juanan already mentioned, the idea of this open discussion is to have our panelists leading the discussion, but participation from the audience is
highly encouraged, both here in the room and remotely. And I won't see now if there are any hands up. So if Ozan, you could flag whether someone has a question remotely, and we'll try to accommodate. And then if in the room, if we have any questions, if you could kindly come up here maybe and ask, or use your voice so that everyone can hear as well. So as our time is limited, we'll see how far we get in the discussion, but we can maybe start by picking up where Odd just left us on this. Sorry, I will go into presentation mode. And just for those of you who have not met me, my name is Linda Hendrickson. I represent the Optimi project. I work for Carr Communications, so I am the dissemination communication partner.
You have brought a lot of flyers here.
We brought flyers, and we have the Optimi banner there to look at as well. So if we just start then by the road mapping exercise that we just heard a little bit about, and the research priorities, as we said, we'd leave it for the discussion now here. So would you, Marcello, like to start by talking us through some of the research priorities and the opportunities in that context, please?
Well, very briefly, because there may be many aspects to highlight about what we have just explained and what quickly shown in the previous slides. I think that the key message is that, of course, the technology environment is changing, the world is posing new challenges, and then it's the right time to think about what would be the requirements for zero-defect manufacturing in the next years. Going more in depth, I would like to stress 2 points of the 5 points that we mentioned before. The first point is basically moving in line with the trajectory that we have just seen through the different steps, waves of projects. We have been trying to gather more data from the shop floor. We have tried to organize data into data management systems in order to gather knowledge out of this data. And then we tried to, in the very recent past, to give meaning to this data by modeling, by control, advanced control solutions, making use of this data, what I've just called data enhanced zero-defect manufacturing. I think that the important message is that now may be time to think about how to rethink processes and machinery because of the existence of this data. We have heard it before from one of the projects that was presented, the idea of the feed-forward control. How can the whole system be redesigned, restructured, enhanced, also from the hardware point of view, in order to make use of this information available and gathered and analyzed in previous manufacturing stages? That's one key question. But also how to make the machinery more adaptable to the real viability, real geometry of parts instead of the nominal as design parts. I mean, these are all questions that are emerging in these projects, but not answered yet. And the other point I would like to stress is the first point that you mentioned in your presentation, the fact that we mainly concentrated on the sweet part manufacturing, but what is about continuous processes, what is really happening and what challenges are on the table when it comes to apply these solutions to continuous processes, to the upstream part of the process chain or the value chain. And of course, also in view of the new manufacturing systems that are emerging in different fields. I mean, just an example, we all know that we are thinking of and trying to move forward the design and development of new gigafactories in Europe. This is the plan for the years to come for producing batteries. That's just new approved product that is supporting the energy transition. But of course, in the first years of production, the system will produce a lot of scraps, a lot of defects. And I think that most of the methodologies that we are developing in this community can be extremely useful to shorten the ramp up of these kind of systems and get to a more stable production in these important contexts. These are just ideas that emerged from the presentation that I've just shown.
I'll add on top of that, Marcelo, I think totally right what you're saying. I think that at the moment we keep an eye on the evolution of the work programs that are coming from Horizon 2020 to Horizon Europe. There's a lot of digital issues, a lot of digital stuff. Sometimes even it's difficult to say, to remind of yourself that this is manufacturing world and manufacturing topics. So in that sense, I always miss that we should keep the balance between all the software, IT, OT, convergence, and everything, the hardware issues, because the cyber physical system, the sensorics, all that is not sorted out yet, is there, and there are still a lot of industrial challenges in there. And the third pillar that we should convert is the sustainability-oriented technologies. Now, perhaps the focus is on the value network, the sustainability, circularity, remanufacturing issues, the hardware associated zero-defect manufacturing challenges and the industry are still there. We are progressing, but I think that if we are keeping the convergence and the balance among software, hardware, and sustainability technologies, I think that we can do a nice way.
Jumping in on what you said there, Juanan, about the new work program, I don't know if all of you have had a chance to look at the programs that Željko was mentioned there this morning that were pre-published. So just a question to you panelists now, do you think, based on what you've seen, are the zero-defect manufacturing priorities focused enough in the new work program? Can they be addressed, even if not explicitly, applied within the other sectors and fields that are more maybe focused or more given more emphasis in the new program? How do you feel about seeing the new 2023-2024 program?
For the 2023-2024, it's more between the lines than it has been for former programs. That doesn't mean that it cannot cover zero-defect manufacturing, especially both when it comes to handling data, solid systems, and also quality issues can easily be included.
Perhaps there's a precision topic, 0102, that can address some zero-defect manufacturing challenges. But most of them, I would say that maybe the transition year, the transition work program, and let's see if from 25 on we can recover again that balance that I was mentioning before.
But there is, as we have shown on many points today, there are many projects ongoing. So in some way, it's also time for harvest and see the way further. That's also it's very good with that new roadmap, and then we can see how it's possible to both communicate with the authorities, the commissions, industry. There's a lot of interest stakeholders there that it's possible to communicate with. So
and
everyone wants zero-defect products from their manufacturing. Everyone wants it.
Yeah. What would be the best way then to get the zero-defect manufacturing agenda driven within the new strategic plan for 2025-2027? So as we know, the public consultation is now starting and will be open for 12 weeks. And citizen stakeholder engagement and ideas and all that is highly encouraged and welcomed. So in your view, what's the best way of driving that agenda to make sure that in the new 2025-2027 program, then the balance is recovered, as you mentioned there?
I think that the multi-annual roadmap of EFRA that I was commenting in the very beginning, also Željko was emphasizing that, is a very solid basis for any future coming work programs and topics. So what is much in our hands and our possibilities is to reinforce the zero-defect presence in that updating, in that upgrading of the roadmap, the RIA of EFRA, because it should be the basis or the reference for the coming 25-27 work program. Additionally, I think that if we are also contributing to the individual consultation phase that will start now, it's important also to address that the manufacturing challenge and the excellent manufacturing is something that is there. And guys, we are talking about the future of our kids, our children, the next generation that want and can to live and work in Europe. So if we want to avoid talent leakage, and if we want to avoid brain drain, I think that we should create an ecosystem here based on manufacturing excellence, supported by all the national and international funding bodies. And among all the community here, I think that we have plenty of good ideas. But this is something that is a responsibility of the whole society in that sense.
because we are talking about the future of the next generation.
Mhm. That's great. And are you optimistic that now the fifth and the sixth wave of projects will feed into that process?
Yeah, that's why we invited them.
Yeah.
I hope maybe you can make them a question. You worked at the new project now, it's going on for 36 or 42 months whatsoever. See the possibility to join this partnership or cluster. And because very much so that is described here what those projects are going to do are really important to communicate. Expectation determination part of those projects are important issues to cover.
Marcello.
Oh, if I can, I want to add one aspect that in my view was clear by looking at all these six presentations, I guess, right?
Yeah,
That they contribute to making visible that zero-defect manufacturing is an important pillar in the energy transition. So many projects were really focusing on pilots and use cases that are related to the energy transition. And I think that this is a core message to transfer through the cluster as well. Because without zero-defect manufacturing, the energy transition may be slowed down or at least may encounter important barriers.
I think definitely we should be addressing the green transition in everybody. Digital transition is already not done, but already addressed with the projects of FOF 11 2020. Now with the new projects today, I think that the green transition is also addressed. We should keep an eye on the evolution, on the progress of these projects, because in 3-4 years' time, when all these projects will be finishing, we should be showcasing very interesting results on the digital transition, also on the green transition, and we should be able to unveil all these technologies and these results to industrial audience. This is something that we have been commented before. To arrange a sort of industrial workshop, I don't know, perhaps multi-sectorial, perhaps just dedicated to a specific sector. Let's see, these are future plans.
And based on the consortia in the new project, it sounds like that the industrial presence is very strong there. So there's definitely a platform to just gather forces in that sense. Yeah. Okay. Then there was an issue, Odd, you mentioned this morning that we'll go into a little bit more detail about the DTI concept sorry, the digital, the decentralized distributed technical intelligence.
Or we are saying something that is quite new, because it was presented in the to the audience in the European manufacturing.
Maybe I use 2 minutes and explain a little bit.
It's just, I think for a lot of us, it would be good to have a.
Yeah, no. Oh, I'm not familiar with your computer.
Technical support.
Just thought it might be good to ensure that we're all on the same page.
It's
perhaps this one.
It's another button.
I think this one. Performance against loop slides.
Yeah, that's the first slide.
There we go.
Just to introduce the concept to someone
quickly,
who's unfamiliar with it.
Björn Soter from Festo, he has been working with the Manufacture High-Level Group, and he has made a white paper covering the decentralized technical intelligence DTI for increased manufacturing performance. Very long title. And it's a very interesting paper he has made there. And he presented this at the manufacturing workshop in September. What if the manufacturing levels could interact autonomously in real time, like in an organic, neutral, social, technical system? It's quite challenging, but I think it's a next level of kind of communication and also quality systems.
Maybe we are talking about the waves number 7. So far, we have been introducing 6 waves,
and here
the doors of the 7th wave.
And here we have picked out 3 issues: high value added network production, high performance production processes, and DTA know-how of engineering, which we see fits very well to the zero defect manufacturing concept. So fast and broad implementation to transform European industry is the gospel there. And there we see also this can go into, and this is something we need to discuss further on with Björn to see how this can fit into the future scope of zero-defect manufacturing. That's the whole thing we are working with, and the white paper is more or less finished.
And the good thing is that you, me, Marcelo, I think we have been participating in this subgroup of high performance production processes. So definitely we should be responsibilized of creating these bridges between zero defects and the new innovative DTA concept. We are not talking about rocket science. It's not something absolutely disruptive, but it's a sort of buzzword that it's gathering a lot of technologies at the multi-level conceptual approach for the companies. Yeah.
Here is a group that has been working with this document. So it's quite broad, and is also communicated with EFRA and also with Manufacture and the Commission. So I think this is also an activity that we can work on, and we also need contributions from other projects, and we need similar lists to go on further on with the zero-defect manufacturing roadmap to get it developed and accepted to some extent of it. Yeah.
Okay. Thanks for introducing us to that concept, and looking forward. Did you say that the white paper is finished but not published yet?
I think you can get some. I think you can find it.
The white paper, I would say that is finished.
Web page now for Manufacture subgroup, and that was attempt to launch further this activity.
The initial idea was to make this white paper now and then go on for a roadmap next year, but it's not that clear, the roadmap plans. We have this roadmap and the other one, our roadmap in .0, we should think always in a convergence.
Yeah, but we need to go on in parallel.
That's it. Well, I will again get back to the presentation of the open panel discussion. Yeah, there we are.
Okay, then maybe just to make it a little bit more interactive, if the floor here, if anyone has any views on specific tips or how to get this cluster and the Manufacture sub-platform to support the ongoing and emerging or new projects that have just started achieving the goals. If any, I mean, we've discussed some of the priorities and the challenges and the ways to achieve goals already, but is there anything from the floor that you would like to highlight that hasn't been mentioned yet? Or out in the virtual participants?
I mean, when we say the cluster, we are always putting in context and putting together the running and past projects on zero-defect manufacturing, but several times, very often, may happen that there's industrial outcomers to these events that are not, by chance, they are not participating in those projects, that they want to be joining this community. Then the Manufacture sub-platform, there are like 8 platforms, which is the Manufacture ETP, and one of them is about zero-defect manufacturing. This is totally open. It can participate whoever involves. It's not necessary to be under any specific project of zero-defect. And in that sense, we are the same guys, you know.
So we are doing both, really. This is more project oriented.
That's it.
And I think the one we are planning next year should be more open.
More open to the audience. It's not necessary to be under any specific project accepted from the Union. So in that sense, feel free to participate, to give us suggestions, ideas, any contribution from dedicated audience will be very much welcome in that sense. And yeah, we are all of us can be the manufacturing of the zero-defect manufacturing community.
Then maybe one more question, linking the role of the humans within zero-defect manufacturing, maybe linking that to the question of Industry 5.0, which also was mentioned earlier today. How strong do you think that evolution is at the moment? That was mentioned within the research priorities as well. Is that something that will be strengthened even more now the human-centered aspects of zero-defect manufacturing in rolling out Industry 5.0? Do you feel that that's the direction we're going in?
Well, I think that automation and all the automatization of manufacturing systems and production systems will be against the current jobs. You know that. But there will be new jobs that will be appearing on the scene. And I think that every time that we are developing new technologies and zero-defect manufacturing, we should consider, we were commenting before the hardware, software, and sustainability. All of this should be around the human-centered manufacturing approach. Thinking on the AI for human empowerment, zero defects for the human empowerment. And every time that we are putting the human in the center of gravity, I think that we should be talking about this industry 5.0 approach in a more realistic, more adequate way.
Marcello.
The projects that we heard this morning, I think that they are the natural transition point towards this concept, because many of your projects have mentioned this implant repair of defective parts or rework. And whenever you have a rework, you have a repair, usually you have something that was not exactly identical as it was before. So you have something where the humans are very important to interpret the digital outcomes and then to take decision on how to actually implement this repair or remanufacturing or rework. So it would be nice to see from these projects what are the requirements emerging for a more human-centric approach, given that this rework or these more intuitive operations are part of your frameworks. I don't know if you want to add something here, but I guess you will have this challenge on how to make information from the digital to the humans that take decision on the real operations on the parts. Any feedback on this? Yeah.
Oscar.
We are
Sorry, I don't. The remote participants probably can't hear you. Do you mind? Sorry.
On stage.
Okay. Well, this is Oscar from Ikerlan. As I say, well, I think we are in this wave where we are trying everything to become almost fully automated. Well, this is not actually the case for every manufacturing process in the industry. There are still some complex processes that maybe not be automatic because it's really so expensive to do. But in that sense, we are, I think a good idea is we have all those digital tools so there that can be used to benefit and ease the life of the workers that at the end need to solve the issues in real time, benefiting of the information and all that stuff. I think is I think we need to consider, for example, in SIDU, we have some use cases that is really focusing in that direction, trying to gather as much information as possible for all the different stuff of manufacturing process and bringing it back to the real work that needs to perform the exact operation to repair it. At the end, this is also a part of zero-defect manufacturing.
On the generation of skills, it's a real challenge on all these things, because especially the digital part. Imagine that you're going like 50 years old, 55 years old, and all the digital wave is so new, so innovative for people that the generation of skills, the training, retraining, upgrading, all these things is making full sense.
Yeah.
And I was hearing recently the creation of that initiative, that is Deep Tech Talent Initiative, that the European Commission wants to create 1 million jobs of deep tech talents. Similar initiatives will be necessary, not only to keep to keep motivated the current workforce, but also to attract the youngsters, because otherwise they will prefer to work like YouTubers or influencers or whatever. We want them to attract to the manufacturing research, just putting the new technologies there available. Yeah.
But I think it comes to the human issues, we are not only talking about people working in the manufacturing factories, we're also talking about people serving the circle in the circular economy, and that you have the upscaling of products, you have the remanufacturing issues and all those kind of things. It will be totally new kind of jobs.
At the moment, don't exist.
They don't exist. They will
We
come.
will create them. Yeah.
But they need to have some kind of industrialization and quality issues, and also using the digitalization, all those kind of things to have a zero-defect manufacturing or zero-defect remanufacturing.
And apart from the technological approach, I think that the service portfolio that should be offering the manufacturing community will be absolutely different in 5 years' time. And the skills generation and all the services that you are commenting perhaps are not in the technological, scientific, technological innovation part, but on the other part that is also necessary. Because the social manufacturing concept is appearing more and more. So we have real, extremely interesting and challenging barriers that I think that we have also the ingredients.
Indeed. These are discussions that could go on for the rest of the afternoon. Now, I'm conscious we've used 25 minutes of time. Is it time to wrap up and continue from here on another occasion when we have a full day workshop, let's say, instead of the 3 hours of today? So if we wrap up, unless we have any, do we have any questions or comments from the remote participants or in the room? If not, I'd like to thank our panelists today, and I'll hand over back to Juanan for the wrap up of the session. Thank you.
Some closing words. I would like to thank you all for your attendance presentially here from the Zoom over there. I think that on the whole, we may be talking about 40 people attendance. I estimate that here we should be around 18, 20. It's another 20 on the Zoom connection. We have the attendance list somewhere else in the room. I don't know where is it now. So thanks also to the EFRA representatives for being present here. Laszlo, representing Hadia, was also here. I think that the quadruple helix should be always in these discussions, not only the academic, scientific, technological, industrial audience, but also the part of the governments, regional governments, European Union, and among them, among all of us, I think that we have huge challenges for this zero defects manufacturing. We'll keep it rolling. Just stay tuned on our website. And our idea is to keep an eye on the progress of these individual projects. And along next year, we would like to arrange another larger presential meeting, but not a 3 hours condensed and concentrated event, but a full day. So many thanks to you all, guys, and take care. Have a safe trip back home today. A big hand for you all. Ozan, we can close the connection to Zoom. Many thanks for your support, for being here, for making this possible.
Yeah, you're welcome. Thank you. Very interesting meeting.
Hope to meet you personally. I don't know when, but we'll find out the way.
Yeah, hopefully.
Thanks, Ozan.
So, thank you very much for everybody.